A very popular concept in probability and statistics is expected value. Expected value is basically the average value of all possible outcomes. So I've broken this down as simple as possible for you by hoping you'll build a table just like I do in the notes. Let's look at this example. Suppose you pay $3 to roll a fair die with the understanding that you will get back $5 for rolling a 3 or a 6. Nothing otherwise. What is your expected value? So let's think about this. Let's call this first row here a win and the second one we lose. So you pay $3. You pay $3 and you don't get that back. That means you've lost that money. That would be your loss. Okay? A -3. It's a negative to your perspective because you've paid it and you don't get it back because you lost. Okay? Now, if you pay the $3 and you win, you roll that 3 or you roll the 6, then they give you back $5. But you've paid 3, so how much are you actually winning? You're actually winning 5 minus 3. That's $2. And that would be a positive value because they're giving you not only the $3 back, but the $2. That's your net value that you win. Now, let's look at what's the probability of winning and the probability of losing. Well, if you win, that means that you rolled a 3 or a 6. So the probability of a 3 or a 6, remember the probability of a 3 is 1/6. It's an OR probability, so we add. Probability of 6 is 1/6. So that's 2/6. And I'm not going to reduce that because I'm going to do a calculation with that. So the probability of winning is 2/6. The probability of losing would be not rolling a 3 or a 6. So the probability of not a 3 or 6 is 1 minus the probability that you do roll a 3 or a 6. So that's the 2/6. So that would be 4/6. Since remember we changed this to 6/6, and 6/6 minus 2/6 would be 4/6. Okay, so now we have the probability that we lose, and that's 4/6. So expected value is the average value of all the possible outcomes. Either you win or you lose. Let's see our average value of those outcomes. So we denote expected value with an E. And what we're going to do is we're going to take our net value and we're going to multiply it by our probability value. And then we're going to add it to our second net value multiplied by that probability value. So we end up with 4/6 plus a -12/6, and that is equal to -8/6 or -1.33. So we do want that negative in there because that's going to tell us if we have a loss or a gain. If we get a negative answer for our expected value, that means we can expect to lose money over time playing this game. If we get a positive value, then that would mean that we can expect to gain money over time playing this game. But we got a negative, so if we roll many times, we can expect to lose $1.33 on average. Now we're going to check this using our calculator, and we can check this using the one variable stats function. So what you want to do is take the net value and put those into L1, take the P of X and store those into L2, and then run the one variable stats for L1 and L2. So going to the calculator, we would press Stat and Edit to enter those values. I've already entered them. I've entered the -3 first, make sure when you enter that negative that you do use the negative key. The negative key is down by the enter key and not the minus. You don't want to use the minus. Make sure you use the negative. When you enter that fraction, when you put in the 4/6, it's going to default to a decimal, and that is perfectly fine. Don't worry about rounding that or anything, just leave it like it is. Then we're going to press Stat, page over to Calc, choose one variable stats. We want L1 in list, L2 in frequency list, down to Calculate, and enter. Look at our mean. The mean, or the average, is negative 0.33, just like we got when we worked this problem by hand. So depending on which method you are more comfortable with, if you want to use the calculator to do these problems, I'm fine, just as long as you know that expected value is the average value of all the possible outcomes. Okay, going back to the slides. Next example. I'm going to actually do these next two examples using the calculator, so as you need to pause, enter it into your calculator, run the one variable stats for L1 and L2, because I'm not actually going to show that information in the calculator. I'm just going to write down what you need to do in your calculator. Okay? So, next example. A contractor is considering a sale that promises a profit of $23,000 with a probability of 0.7. So that's straight profit. So $23,000, that's our net value of our profit. And that would be a positive value because we're gaining that amount. The probability that's linked to that is 0.7. Or a loss due to things such as bad weather, strikes, and such, of 13,000. That would be negative. Making sure you get that negative value in there for your loss is very important. So, the probability linked to that is 0.3. What is the contractor's expected profit or loss? So, if we get a positive value, that means he has an expected profit. If we get a negative value, that means he has an expected loss. So what we're going to do is take our net values and we're going to store them in L1. Make sure you use the negative on the negative 13,000. We're going to take our P of X and store them in L2. And we're finding the average value of these two possible outcomes, a profit or loss. So, running the one variable stats for L1 and L2, you'll see that our margin of error, which was the mean on the calculator, is a positive 12,200. That means he has an expected profit of $12,200. We have one last example. A 28-year-old man pays $57 for a one-year life insurance policy with coverage of $100,000. If the probability that he will live through the year is 0.9992, what is the expected value for the insurance policy? Okay, so let's make the first row he lives and the second row he dies. So the probability that he lives is 0.9992. What's the probability that he dies? Well, the probability that he dies is 1 minus the probability that he lives. So that's 1 minus 0.9992, which is 0.0008. Now, what values were linked to those? If he lives, it says that he will receive, or his estate will receive nothing. If he lives, he's paid $57. So when he lives, he's actually losing money. Negative $57. If he dies, then his estate receives $100,000. So he's lost 57, he paid 57. We need to know the net value. So the net value of dying. I think that should be D-Y-N-G, dying. So that would be $100,000 minus 57. And that is 99,943. So our net value, 99,943. We've built our table now. We know our net values. We know our probabilities. Let's store our net values in L1, our probabilities in L2. Run the one variable stats for L1 and L2. Find your value for X bar. That's your E. $23. That is your, or his, expected value for each income over many trials. So over many years if we extended this to more than 1 year.